We all know the exhausting reality of traditional software development. You sit down to solve a complex architecture problem, but first you have to spend hours typing out boilerplate code, standard syntax, and redundant functions. It is like turning the crank on a massive, heavy machine just to get the engine to start. We know AI can automate this manual labor, but right now, developers are facing a flood of overlapping tools, which usually leads to paralyzing choice paralysis rather than actual productivity. To cut through the noise, let's look at this quadrant chart. The horizontal axis maps our workflow from manual effort to automated generation. The vertical axis maps our focus from low-level syntax execution to high-level architectural logic. Without AI, traditional development traps you right here in the bottom left. You burn huge energy just executing manual syntax. Using AI tools moves your focus from the mechanics of typing to the architectural logic of the system. You are using automation to clear the low-level work so your brain can stay in the top right quadrant. Reaching that level requires navigating three distinct categories: standard IDE extensions, AI native code editors, and separate browser-based chatbots. It is tempting to simply turn all of them on at once, but throwing unmanaged AI at your daily workflow creates hidden structural problems. The specific risk here is hallucinated code. An AI might invent variables or logic that looks correct on the surface, but introduces a structural failure into your software. If you spend 3 hours tracking down a silent logic error introduced by the AI, you have entirely wiped out the time you saved by not typing the syntax manually. Adopting AI requires a direct trade. You are swapping the time spent writing syntax for time spent performing rigorous architectural oversight. Let's evaluate the options, starting with GitHub Copilot. This is the lowest friction entry point for AI integration. The operational input is simple. You pay a subscription, install a basic extension into the IDE you already use, and you are immediately up and running. This comparison matrix shows where Copilot excels. Its primary function is line-by-line autocomplete. It acts as a real-time prediction engine that clears out boilerplate code as you type. But that speed comes with a strict limitation. Copilot operates with a shallow context window, meaning its understanding is typically limited to the single file you have open. Because it cannot see the broader architecture of a massive project, it will occasionally invent functions or reference variables that do not actually exist in the rest of your codebase. It is highly effective, but it demands constant micro-supervision. If you accept its suggestions blindly, you will accumulate immediate technical debt. Next is Cursor Editor, which functions as a standalone replacement for your current editor. Migrating requires significant initial friction. You have to break your old muscle memory, transfer your extensions, and rebuild your specific workflows inside a brand new IDE. But looking back at our matrix, Cursor provides a return on that effort through its context depth. It offers complete codebase-wide integration. This deep context allows Cursor to execute complex refactoring across multiple files simultaneously. It understands the ripple effects of a single change across your whole system. The critical constraint here is data privacy. Enterprise developers often face bottlenecks because they are legally restricted from sharing proprietary code-based telemetry with an external AI platform. Provided their security policies allow it, Cursor makes the developer a conductor of entire systems. Finally, there are the out-of-bounds tools like Claude 3.5 or ChatGPT, which operate entirely outside your IDE. The trade-off is workflow friction. Operating a separate browser-based chatbot forces constant context switching and manual copy-pasting, breaking your flow state. But checking the final row of this matrix reveals where Claude outperforms IDE tools, explaining complex logic, plotting system design, and generating exhaustive documentation. Despite the friction of leaving your editor, utilizing Claude is necessary. Architectural brainstorming requires an isolated environment where you can weigh logic without the distraction of executing syntax. Attempting to balance all three of these tools simultaneously usually leads to more friction than speed. To find your ideal setup, we can use this decision tree. You start by identifying your primary constraint as a developer. If you are an enterprise or senior developer locked into corporate security policies, choose Copilot for your local boilerplate and keep Claude completely separate for non-proprietary brainstorming. Alternatively, if you are a time-poor solo developer or indie hacker prioritizing raw deployment speed, adopt Cursor immediately. The multi-file editing speed easily offsets the friction of migrating. Ultimately, your codebase environment dictates your AI stack, not the other way around. There is one last demographic we need to address: junior developers and learners who are still building their foundational skills. If you belong to this group, avoid relying on Copilot's autocomplete. Bypassing manual syntax writing early on causes skill atrophy. It is the difference between building a solid stone foundation block by block and resting your career on thin, hollow stilts. Instead, use Claude 3.5 strictly as an interactive tutor to explain complex code to you, rather than having it generate the answers for you. The real value of AI coding is only realized when you accept the trade-off. Automating your keystrokes requires you to spend that save time as a rigorous auditor of logic. Evaluate your constraints and choose the tool that matches the project in front of you.